Every time an enterprise scales its AI infrastructure, a silent financial leak scales right alongside it. You end up paying repeatedly for the exact same expensive LLM computations. The root cause is simple human variation. One user types, "How do I reset my password?" and another types, "Change my login credentials." They are asking the identical conceptual question, just with slightly different phrasing. Standard caching misses this completely. Because it relies on exact string matching, if characters don't align perfectly, the system fails to recognize the duplicate. As a result, both requests bypass the cache and hit the language model, instantly doubling your processing burden. Now you are hit with a dual penalty. Your application is waiting over 2 seconds to generate identical output, and your finance department is getting billed twice for the exact same data. When you extrapolate this across thousands of daily users, normal human variation transforms from a minor inefficiency into a compounding financial drag. Traditional exact match systems are blind to human intent. To optimize generative AI, we need a system that reads past the spelling and understands the actual request. To eliminate this waste, the system must stop looking at the superficial spelling of a prompt and start evaluating its underlying meaning. We achieve this by converting language into math, using a concept known as embeddings. Here we see an embedding model at work. It takes the conceptual meaning of a sentence and plots it as precise mathematical coordinates within a vast, multi-dimensional space. Reset password and change credentials are mapped right next to each other. Within this space, the physical distance between these plotted points acts as a direct, quantifiable measurement of their conceptual similarity. By translating language into geometry, we definitively measure the proximity of two ideas and strip away superficial word choices entirely. This brings us to the vCodex gateway, an active defense layer positioned directly between your users and the expensive LLM to analyze these vectors in real time. When a new prompt arrives, the gateway instantly isolates it, freezing it out of the main data stream before it racks up compute costs. The gateway then runs a rapid verification step called a Cosine similarity check against a LanceDB vector database, mathematically comparing the new prompt against a library of past queries. We set a strict threshold. If the math shows a confidence mark of 0.95 or higher, the gateway intercepts the call and serves the cached response instantly. This mathematical intercept breaks the link between growing user volume and rising API costs, allowing you to recycle existing answers without ever pinging the LLM. Zooming out from the microscopic data operations, we can look at the macro-level realities of deploying this infrastructure in a live production environment. Activating this defense network does not require a structural overhaul. It takes exactly one line of YAML configuration to flip the system on. The impact on network traffic is immediate. In this workload, activating semantic caching eliminated 25% of all production queries. This dashboard shows the leverage of that intercept. While we only removed a quarter of the queries, those specific requests were the most token-intensive repeats in the workload. By catching them, batch costs dropped 75%, plummeting from $47 down to $12.50. And because we bypass the LLM entirely for those queries, the average processing time is slashed by 55%. You can start dropping redundant queries from your own infrastructure today by visiting the vCodex.ai. True enterprise scale is achieved not by buying more compute, but by refusing to compute the same thought twice.